this video, we're going to look at metallic bonding. Metals are made up of a giant lattice made of layers of ions. Giant lattice means a regular repeating 3D arrangement. As you can see in the picture, the large grey spheres with the positive symbol are the metal ions, and they are arranged in layers. Now, in real life, this would be 3D, three-dimensional, but in the picture, this is only 2D. Why do metal atoms form a giant lattice? Well, if we look at the electronic configuration of a lithium atom, we can see that the lithium atom has one electron in its outer shell, and it needs to lose this electron to have a full outer shell and be stable. So if we have lots of lithium atoms all together, they can all lose their outer shell electron to have a full outer shell and become stable. When this happens, these electrons become delocalized. Delocalized means free to move. The delocalized electrons, shown here, are free to move around the giant lattice between the positive metal ions. And the metal ions are positive because they have lost one electron, so they've lost one negative particle. This would happen in other metals as well, because metals lose electrons to become stable. So why does the metal stay together? Well, the sea of delocalized electrons is negative and the metal ions are positive. Positive metal ions are attracted to the sea of negative delocalized electrons. This is metallic bonding. Now, these forces of attraction are called electrostatic forces of attraction. Now we're going to look at the properties of metals and explain them using what we know. Metals are malleable. This means they can be bent and hammered into shape. Metals are also ductile, which means they can be drawn into wires. Why are metals malleable and why are they ductile? Why can they be bent and hammered into shape and why can they be drawn into wires? Well, it's because the layers of metal ions can slide over each other when a force is applied, something that looks like this. Metals are also good conductors of thermal energy and electricity. And this is because the delocalized electrons are free to move throughout the giant lattice. So the electrons can transfer charge and form an electric current, and they can also transfer thermal energy along the metal quickly when the metal is heated. Metals have very high melting and boiling points. This is because the electrostatic forces of attraction between the positive metal ions and the sea of negative delocalized electrons are very strong and require a lot of energy to overcome, so a high temperature is needed to melt or boil a metal. Remember that the electrostatic forces of attraction act in all directions, and they require a lot of energy to overcome and separate the ions from their fixed positions when the metal is a solid. Because it's a good conductor of electricity and ductile, we use copper to make wires. Because it is malleable and has a high melting point, we use aluminium to make pans. These are some examples of the uses of metals. Now I want you to pause the video here and try these 5 questions. Here are the answers. Like the video if you got 5 out of 5.